Hey people, welcome back. And in this session, we will be learning practically how to validate the measurement system when data is continuous in nature. So we already know measurement system analysis, MSA, we do for the validation of source of data. Source of the data, I was telling about it's simple PPT, which is the people. The data is coming from they are measuring, which we also called as an operator. We have process or the method we are using to collect the data, or we have the technology, which is the instrument we are using to collect the data. So we are validating these. So there are altogether, we have the three type of MSA for the continuous type of data. These three type of MSA we used crossed. Crossed MSA we use when the same part is available for repeated testing. In simple term, I will say this is a non-destructive testing, which means the same sample, same example is available or same part is available for the again and again test. Then the second we use the nested. Nested we use when the same part is not available, but you have the similar part, like as one machine only is running, producing the one batch of the product, and one you are doing the destructive testing here. And in the destructive testing, as suppose we are doing some kind of drop test or strength test, when the same part will lose their original strength. So same part is not available, but the similar part from the same batch or the similar batch or the similar machine is available. Then we use the nested. And the third thing or the third type, we use the expanded. Expanded we use when same part is available, maybe from the crossed or maybe from the destructive kind of thing, but there is an additional factor is impacting that. Suppose you are using additional factor. When I say, you can say like as you have the two machine A, machine B, where the same product you are manufacturing in the same specification, machine is with the same make, but machine 1 and machine 2 you are using, maybe you are using sometime the location, like as one location is at X place, another location is at the Y place, or maybe you are using like as some part you are measuring in the morning shift and some part you are measuring in the evening shift. So the factor, which is the environmental factor, is impacting your output or not, then we use the expanded MSA. So we have collected the data. We already know the rule. Rule number 1, that my percent study variation is always lower is better, must be less than 30% is what the max limit. And the rule number 2 is number of distinct category, which is always higher is better, must be greater than or equal to 5. This is what we'll be validating. So I have a data. Let's understand this data. The part or the product which we have, I have taken here 4 product. And I have 3 operator, Amit, Deepika, and Maitri. And for each of the operator, I am taking 2 trial. So first trial when Amit did the measurement, A, B, C, D 4 part, and here we recorded the value. Now the same part, Amit is measuring again, and I'm recording the value. So the difference in the first value of Amit versus the second value of Amit, if I calculate this in percentage, that is called your repeatability variation. So same way as Deepika is measuring the part A versus Deepika is measuring the part B, and Deepika is measuring part C first time, and the same part A, B, C is measured second time. So the difference of part A first time versus the part A second time, this is the repeatability variation for the Deepika. Similar way for the Maitri, the part A is value is 0.902 and part A value is 0.896 for the second time. So difference between 0.902 and 0.896, this is the repeatability variation for Deepika. When you say reproducibility, if I calculate what is the value of Amit on an average for the part A versus the value of Deepika on an average for the part A, the difference of average of Amit versus average of Deepika is called as an reproducibility variation. And the sum of repeatability and reproducibility variation is your total variation, which is also called as an steady variation percentage. Environmental factor, I am adding here for the machine A or B, two different machine I am using. So this calculation will be using the expanded when we are using the expanded one. So I will be running all these three MSA on the mini tab now. I hope all the calculation understanding, basically the background of calculation, background of data is clear. So let's see how the MSA will be reading and how these two value will be reading about the percent variation as well as the number of distinct categories. Here I copy pasted this data, and first we are going to learn about the crossed MSA. Let's say we'll go to the stat, quality tools, gauge study, and here we select the gauge R&R study crossed. Just click on this. Part number are A, B, C, D. So double click on part number will come here. Then operator, I have Amit, Deepika, and Maitri. Here is the operator. And the measurement data is the output, which is here. By default, ANOVA method, let it be everything as it is and click on OK. Now you will see the result. I have to see two main important things. One, what is my total study variation? And the second, what is my number of distinct category? So if I look at this table, last table, my percent study variation or total gauge R&R here is 8.15%. And my number of distinct category are 70. So rule number one, study variation should be as lower as better, less than 30% acceptable. And when my variation is less than 10%, so from the variability point of view, it's perfect. I look for the distinct categories. So distinct categories are more than 5 is 17. So my measurement system is perfect here as well. How my measurement system with respect to the pupil, operator, and product is doing, I can look at these graphs. If I look at the last graph, which is the part and operator interaction. So that will give you the almost summary in a graphical way, like as part A, B, C, and D are here. And three operator represented by blue, red, and the green color, Amit, Deepika, and Maitri. Almost they are measuring the part A, all three operator giving you the same value. Same for the part B, same for the part C and the D. All three operators are using the same output, which indicate to us that there is no variation among the operator. Whatever the value they are measuring, they are consistent enough. Now, I look for the R chart by the operator, and you see R is the range, and range represent the variation in the process. So variability between Amit, Deepika, and Maitri can be seen here or among these three, and the total variation in my process is about the sample range, which is 0 to 0.04 is going. If I ask you the question, which operator is showing the maximum variation or lowest variation, like as who is consistent, who is not consistent, so you see the difference of Maitri, part A, B, and C, when the second and first time and the second time difference is very, very low for the Maitri, which means Maitri is very consistent except for the part T when C has shown a variation little higher than the overall variation average or range average. If you look for the Amit perspective, Amit for the part A, part B, part C, and part D, you see the highest variation among the three operators shown by the Amit. So in case further you are looking for some improvement to bring some consistency in the process, you may look for the Amit to improve first. Please remember, R is the range and range is the measurement of variation. So variation or R chart must remain within the control limit, and actually it is. This is your upper control limit, this is your lower control limit. So my R chart is very well within my control limit. Now I look for the average chart, which is the X bar chart by the operator, because two products are different in nature, like as A is different from the B, B is different from C, and D, and so on. So the values of these product will be different. So of course, understanding because my variation in the process is very low and my average value will be different. So my average chart must go outside the control limit because average of two product cannot be same. And your variation in your control and control limits are based on the variation like as plus or minus 3 standard deviation. When the average can be different, variation is in your control. So of course, it is understandable that my average chart must go outside the control limit. So these are the three graphs will give you the understanding in a graphical way. If you want to study the statistics further, So then your repeatability is this much percentage. So basically problem is coming from the repeatability, which we can see from the R chart as well, that Amit and Deepika are showing the variation, even Maitri is showing the variation for the part D. They are not able to repeat their exact result, but still, because your range variation is very low, so repeatability approximately 8.15% is understandable or within our acceptable limit, as max limit is for the 30% of the sum of the repeatability and reproducibility. And if I see the reproducibility variation is very minimum, almost zero. Maximum variation, because these four parts cannot be same. So these four parts are different from each other, and that is what the part to part variation is highest, and this is what should be. Almost 100% it should be. There shouldn't be any repeatability variation. There should not be any reproducibility variation. Now looking some statistics behind that. So first table is the two-way ANOVA table, because four part cannot be same. I explained in the hypothesis. A hypothesis says if there is a difference, p-value will be less than 0.05 alternate hypothesis. And I see four part cannot be same. They should be different from each other. And this is what proven by the statistics as well, that I am clearly able to identify that these four parts are different. Now I look for the operator, because operator either Amit is measuring or Deepika is measuring or Maitri is measuring. They should be able to produce the same result. There should not be any difference, which is proven by my hypothesis p-value as well, because p-value is greater than 0.05. It's a null hypothesis, and null hypothesis says there is no difference. When the part and operator interaction is happening, for the Amit, Deepika and Maitri, part A, B, C, D, even whatever Amit is measuring part A or part B, or maybe Deepika is measuring part A or part B, they are consistent about result. There is no influence of the whichever the part they are measuring. So this p-value is also good for me. It should be greater than 0.05. This is the way we'll be measuring some other variation component, which you really need not to worry. The important part, you have to see the what is your percentage study variation should be less than 30%, which is lower is better. And your number of distinct category should be greater than 5, which is 17 here, and it is good for us. Now, exactly in the similar way, we'll be doing the nested and the expanded. Suppose I have the same data. I go to the stat, go to the quality tools, select the gauge study, and select here is the nested. Nested will be used when we are doing the destructive testing. Again, you will select the part number, select the operator, select the measurement data. That's all. Click OK. And exactly in the same way, you will be reading it. So my study variation here is 9.40 because it's expanded. So calculation will be different based on the standard deviation. And distinct categories are 14. And still I can say, even for the nested, if I have the same data, my measurement system is successful. There is not significant variation. My R chart is very well within the control limit, and my X bar chart is outside the control limit. Perfect. If I consider the data, like as machine A or machine B, these parts are coming first ABCD from the machine A and the second ABCD from the machine B. So then I will be using the expanded, because there is another categorical variable which may influence my output. So we'll go to the stat, quality tools, gauge study. We'll go for the gauge study R and R expanded. Select your part number, operator, measurement data, and additional factor which you have is the machine. That's all. Click on OK, and here we go. And the results in front of you. Similar way, we'll be reading what is your study variation percentage, 8.18%, distinct category 17, R chart within the control limit, average chart outside the control limit, and you can see part and operator interaction is perfect. So this is the way we validate our measurement system. I will be explaining you about the attribute agreement analysis in the next session. Thank you so much, people.